Hello, Math 2 students. What I'm doing is I'm putting formative 1 and formative 2 together, and we're going to walk through it together. All right. So the best thing for you to do as I'm doing these problems is to see if you can kind of figure out the answer ahead of time or something ahead of time. Don't just wait for me. Okay. So the first question is draw each of the following items on the circle below: radius, diameter, chord, tangent, central angle, inscribed angle, and label all points used. All right. It says name each of the following on your diagram. So I'm going to start with A, and I'm going to put a center. I'm going to call it O. Oh, there we go. I'm going to call it O. So the center of the circle is circle O. Now they want a radius, right? So from O, we have to go out to the edge. And they need you to name that, so let's call that A. So my radius that I'm going to show is OA with the segment symbol above. Then a diameter, okay, is a chord that goes from one end all the way through the center. And I can call that B and C. So diameter BC. Now a chord, I don't want the diameter. I want to do a different one. So I want to do over here. I'm just going to do this. Let's call this DE. DE. Right? Because a chord has its endpoints on the circle. Now a tangent line, remember a tangent line is some line that's, let's put it right there. All right, it only connects with the circle at one point. And let's put some points on here. Let's call it F and G. So my tangent line is F, G. Now they want a central angle. Well, I have a central angle. That angle is from, and I'm just going to highlight it for you real quick, and then I'll take off the highlight. It's from A to O to B. Remember, central angles, the vertex is at the center. So I'm going to take that off. Oops. Put this back on. And it's called angle AOB. Notice the vertex, that middle letter. Now an inscribed angle is different. Okay, so what I'm going to have to do for an inscribed angle, let's do it this way. I'm going to do, it's going to get kind of hairy in here. So I'm going to do this way and this way. And I'm going to call this HIJ. So this angle from shouldn't have done that. I'm going to highlight from HI to J, that angle there, the vertex is on the circle, okay? That vertex is here. All right, so let's see if I can get rid of some of this. There we go. And so we have angle HIJ. All right? Your diagram does not have to look like that, but that's the first question you're going to have to be able to do. Number 2, identify inscribed angles or a central angle. So we're going to check all these angles. Remember, an inscribed angle, vertex on the circle. Central angle, vertex at center. All right? So what you have to do is look at each one of these. All right? So UQT, I'm going to use this. From U to Q to T. So the vertex is here, right? So that means that is an inscribed angle. So then get rid of all this junk. From V to S to Q. So from V to S to Q. So S is the center, okay? So that's a central angle. Okay? From T to S to R. T to S to R. The S is the center, so that's central. S to T to Q. S to T to Q. That vertex is here, right? So that vertex is on the circle, so that's inscribed. Go to the next one. P to Q to T. From P to Q to T. Q is the vertex. It's on the circle, so that's inscribed. And last but not least, U to S to Q. U to S to Q. That's a straight line. That's a straight angle. It's still an angle. That middle letter is the vertex. That vertex is at the center, so that's a central angle. Okay? So they try to trick you with that last one. All right? Number 3. State at least one difference or similarity between a central angle and an inscribed angle. Use complete sentences in appropriate mathematical vocabulary. So, we know that the central angle equals the arc, and we know the inscribed angle equals 1/2 the arc. So, we know the inscribed angle equals 1/2 the central angle. So that's what you have to do. You have to be able to write that. So, you need to write a statement that is the inscribed angle is equal to 1/2 the central angle's measure. You need to do that here. Okay? I'm not going to write that all out for you, but I showed you what it was. Number 4, okay? Determine the measure. So now we have a central angle. We have an inscribed angle. Okay? Notice where they both come on. They intercept the same arc. And that arc we can call FG. All right? So they're telling us FG equals to 110. So we need to find FEG, which is the central angle, and we just said the central angle equals the arc. So if that is FEG is equal to the arc 110, that's easy. And we just said the inscribed angle is equal to 1/2 the central angle because they go to the same arc, so we have to go 1/2 of 110, which is 55. And now they're going to try to trick you. This is a major arc. So this arc here, let me clean this up here so we get this stuff out of our way. All right. This arc is from F to H to G, so it's out here. So if you remember that a circle is 360 degrees, and if this part here is 110, then we just take 360 minus 110 to figure out the other part, the outside part. Okay? So 360 minus 110, and that equals 250 degrees. Okay? Evaluate. All right. Please excuse my dear Aunt Sally. We have subtraction, division, addition. So I'm going to do the division first. So 10 minus 18 divided by 2 is 9 plus 4. Now I have subtraction and addition. They're both the same level, so I do the one on the left first. 10 minus 9 is 1 plus 4 is 5. Up here, number 6, remember you do the top stuff. All right, we do the top first, so I'm going to do inside the parentheses. So that's 3 times 1 times 2 is 2. That's over 5 minus 2 squared. I'm going to do the top still. 3 times 2 is 6 over 5 minus 2 squared. Now I'm ready to do the bottom. I have subtraction and I have exponents. Do the exponent first. 6 over 5 minus 4. 2 squared, 2 times 2. 5 minus 4 is 1. 6 over 1, which is 6. Simplify meaning I'm collecting like terms. So I have this to collect and those to collect. I have the A terms. So if I have 4 A's and 9 A's, I have 13A. If I have 6 B's and I subtract 7 B's, I have a negative 1B, or 13A minus B. Either one is correct. All right, we just did bisection of an angle. It says draw and label the representation. So we have this angle, so let's draw it. And it's A, B is the vertex, C, and I know the vertex is the middle letter of the angle. And now BX bisects it. So let's do this. Okay. And we have to label it. So to show bisection, we're going to do congruent marks, those congruent tick marks. It says write a conclusion. Well, what we know is that angle ABX is equal to angle XBC, right? That's the conclusion. If we have a bisection, then we know that the two angles it creates are equal to each other. It says given XYZ is a central angle in Y, draw and label, okay? So we're going to draw, okay? We're going to put a center, which is Y, and we're going to give a central angle. So this is X up here and Z over here, all right? Write a conclusion based off the picture. Well, we know that angle, the measure of angle X, Y, Z, whatever it is, it has to equal the arc XZ. Right? We know that. We know that the central angle equals the arc. We just went over that. Calculate the measure of TUV. So this angle out here. So they want this angle here. Okay? So with that said, this is the triangle sum. We know that this angle plus this missing angle equals 180. So 40 plus 85 plus X equals 180, which is just 125 plus X equals 180. And subtract the 125 off both sides. And we get X equals, that looks like 55. Good work. All right, if you remember from yesterday, we have an exterior angle of a triangle, and that exterior angle equals the sum of the two interior angles. So 146 equals the sum, 77 plus X. So to figure out that missing value, the missing one, we solve. And then it cancels X equals. And let's see here, we have 77, it looks like, let's see here, 77, 69, is that correct? That looks like, that looks correct. All right, please check my math here because I'm doing it really quick in my head. So if I do that, 1, 3, carry 1, that's 9, that's 6, yep, that works. Okay. And then we have solving the equation, simple two-step equation. We add 2, and 3x equals 7, divide by 3, and x equals 7/3. Leave it a fraction, no big deal. Now this number 6 we haven't done yet, although that's one of the next steps we're going to do. And what we're going to do is get the variable to one side after we simplify. So you're going to have two sides, both sides of the equal, looking like two-step equations. So let's collect like terms here and here. Oh, not there. Okay. So we get 5x plus 2x is 7x plus 2 equals, and then we'll collect over here on this side. 3x, 7 minus 1 is 6. So now we'll move the variable to one side. So I'll subtract 3x off both sides. That keeps it equal, and it moves the variable to one side. I get 4x plus 2 equals 6. Now you're up to your two-step equation. Subtract 2. 4x equals 4. Divide by 4. X equals 1. All right, if I'm making mistakes, you gotta let me know because I'm moving very quick. So here we're gonna distribute. Whenever you have a negative sign in front of the number to distribute the whole negative. So we're gonna write 3. Negative 2 times positive 4 is minus 8. Distribute the negative again. Negative 2 times positive 3 is a negative 6x equals 19. Now we're gonna collect like terms. So we have 3 minus 8 is negative 5. Minus 6x equals 19. So we're going to get rid of the 5 or the minus 5. So we're going to add 5. We get, don't forget to bring that negative down. Negative 6 equals 24. Divided by negative 6. And x equals 24 divided by negative 6. Positive divided by negative is negative. 24 divided by 6 is 4. Okay? Not too bad. And then all the scores will be put here. You know how that is. 4, 3, 2, 1, 0. Those are the indicators that you have to start to work for. But now we're going to move down to, I'm done with that one. What I'm going to move down to is the exponent rules. This is something you need to commit to memory. If you were in Math 1 last year, we did go over this, but I'm going to go over it quickly again as well. So these are all the rules that you have to know how to deal with exponents, okay? They're not easy. This one, we're not going to worry about. But every other one we're going to do, okay? So an exponent, it is just a way to show multiplication of the same number in a shortened form. So x to the fourth means x used 4 times in multiplication. Y to the seventh means y used 1, 2, 3, 4, 5, 6, 7 times in multiplication. Okay, so 3 to the fourth power just means 3 times 3 times 3 times 3. All right, it's not 3 times 4. Okay, 3 times 4 is 12. This is going to get you a big number. Okay, I think it's 81. So we have what's called a multiplication rule. If they have the same base, now remember, the x is the base, the 4 is the exponent. The y is the base, the 7 is the exponent. The 3 is the base here, the 4 is the exponent. So if you have the same base, so x to the 6th times x to the 3rd, so the same base, and you're multiplying them, all you do is add the exponents to do the multiplication. It becomes x to the 6 plus 3, or x to the 9th. Okay? Y to the 2nd times y to the 3rd. They're common bases, so it becomes y. Its multiplication, 2 plus 3, is y to the 5th. With division, opposite of multiplication, we're going to use subtraction. We have common bases, so this becomes t to the 6 minus 2, or t to the 4th power. Again, we're dividing common bases. That becomes r to the 12 minus 11, or r to the 1. Anything to the first power is just itself. Okay, so either one I'll accept. Raising a power to a power. So you have this x to the 3rd power raised to the 4th power. What that means is the 4th means we're going to use this in here 4 times. X to the 3rd times x to the 3rd times x to the 3rd times x to the 3rd. Remember, we use that 4 times. And if you go back to our multiplication rule, we have common bases. So this becomes x to the 3 plus 3 plus 3 plus 3, or x to the 12th power. So an easy way to do raising powers to powers is to multiply the exponents there. X to the 12th. Okay? But that's only raising powers to powers. So s to the 2nd raised to the 3rd really means s to the 2nd times s to the 2nd times s to the 2nd. And we know that means s to the 2 plus 2 plus 2, or s to the 6th, or I can just multiply those. S to the 2nd raised to the 3rd, 2 times 3 is 6. Gives you the same answer. Okay? Power of a product rule. just multiply the exponents to each other on the inside. So I have a times b. So this is being multiplied on the inside. So what this really means is a to the first times b to the first raised to the fourth. And what does that mean? That means a to the first, b to the first, times a to the first, b times the first, times a to the first, b to the first, times a to the first, b to the first. Why? Because there's 4 of them, because you're raising it to the 4th power. And all we do then, okay, and I want to move over here because I want to need more room and I'm going to rewrite it. We can rearrange all this. This is a to the first times 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 b 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 to the first. And we know this is a to the 4th, and we know this is b to the 4th. So we did all this work to get to here, when here, I'm going to show you the quick way is distribute this in to the exponents. This is a to the first, b to the first, raised to the 4th. Multiply that there, multiply it here, you get a to the 4th, b to the 4th, which is that right there. So let's do the shortcut with this next problem. We have x to the first, y to the second, raised to the 4th, distribute x to the 4th, distribute y to the 8th. Done. Okay? Exponent rule. Anything to the power of 0 equals 1. X to the 0 power equals 1. 5 to the 0 power equals 1. If I do this work, if I do x to the first, y to the first, raised to the 0, if I distribute that in, that's x to the 0. 0 times 1 is y to the 0. That is 1 times 1, which is 1. Anything to the 0 power is 1. Okay? And now anytime you have a negative exponent, to make the power positive, you use the reciprocal. Okay? So we always want our exponents to be positive. So a to the negative 3rd, to make the exponent positive, we just do the reciprocal. We do 1 over a to the 3rd. So really, a to the negative 3rd is really over 1. Everything is over 1 if it's sit by itself, so you just flip it. Okay? So if we take this, it's really x to the negative 6 over 1. We flip it. 1 over x to the negative 6. Okay? So that's here. That's here. T to the negative 2 is really t to the negative 2 over 1. We flip it. 1 over t squared. Okay? And so this one, it was written wrong. It should be 1 over t to the negative 2 power. And so now we flip it up like this. It is t to the positive 2 over 1, or t squared.